So here we go, continuing with number 15. If we look at which ones of these is polar, you've got a C and an H2O. It's going to look like this. I'm going to assume that you know how to draw the dot diagrams and not take time to describe how to draw each one of them. Except maybe this one. So BRF3 is it's going to be a T shape, and I'm going to show you why. There's our 3Fs. There's a little scrunch right there. Okay, bromine has 7 valence electrons, and fluorine has 7 also. So 7 times 3 is 21, plus 7 is 28 valence electrons. I have 6 in the picture. That gives me 22 still to put in. So if I put 6 here, and 6 here, and 6 here, that's 18, 19, 20. And now I'm out of spaces, so I have to put the extra ones around the middle. So you see I've got 5 domains. 5 domains. 3 are shared, 2 are unshared. That's T-shaped. All right, HCN looks like this, so it looks like that, and the electrons are going to shift, the charges are going to shift in the direction towards the more electronegative elements. So from H to C it goes towards C, from C to N it goes toward N. So the electrons move this way, this end being negative and that end being positive, so that's polar. Same thing happens down here, the electrons go to the fluorines out like that. The negative is going to be somewhere over here, positive over here. Barrett, that is my dog. He thinks he needs to go outside, so he's trying to open the door by putting his mouth on the doorknob. All right, and then we have electrons shifting toward the oxygen here and toward the carbon here. So these guys are going to cancel each other out, or not going to cancel each other out either. So the only place where they do cancel out is carbon dioxide, which looks like this. And that creates then a nonpolar molecule because the electrons are going to move toward the oxygen like that and toward the oxygen like that. So since they're opposite directions, but in the same line, they're going to cancel each other out, and the molecule will be nonpolar. So the answer is D. All right, so this one is the answer. All right, over here, which has 90-degree bond angles, you got to draw them again. So you got an H2O, looks like this. Since these unshared electrons are there, it's going to make them 109.5, actually a little closer than that, 104. Ammonia, if you look at your chart, it will be 107. Carbon tetrachloride, tetrahedral, be 109.5. SO3 looks like this. I didn't put the 6 electrons on all of these, but they're there. Okay, so the only one that's left to be 90-degree bond angles, those are 120, right? 120, 109.5, 107, 104.5. So that leaves us with XeF4, which looks like this. It's going to have 36 valence electrons, so 36. 8 are in the picture, so that gives us 28 to put in. So you put 6 here, and 6 here, and 6 here, and 6 here, and that makes all the fluorines have 8. You have 4 more electrons to put in, and they have to go around the center. So it becomes a square planar, and this angle right here is 90 degrees. So right here. Sorry for me to draw 90 degrees, but anyway, that's a 90-degree angle right there. Okay. Number 17, which one requires expansion of the octet in order to minimize the formal charge in the center atom? Well, water looks like this. So formal charge would be 6 minus half of the shared electrons. There's 2 here and there's 2 here, so half of that is 2. Minus all of the unshared electrons. There's 2 here and 2 here that are unshared. That's 4. So 6 minus 2 minus 4 is 0. pH 3, dot diagram looks like this. So 5 valence electrons minus half of the shared, 1, 2, 3. So 6 shared, but half of that's 3, minus 2 is 0. Carbon is 0 here also, and carbon, I just go up here. If you look up at the top, I just drew this picture, so you'd have 4 minus 1, 2, 3, 4, half of the shared electrons. And there's 8 shared around the carbon, so half of that would be 4, and 4 minus 4 is 0. So the carbon's formal charge is 0. But the sulfate, that looks like this. It has 32 valence electrons. If you draw it like this, it meets the requirements of the octet rule. But the formal charge on the sulfur is 2, because you'd have 6 minus half of the shared, 2, 4, 6, 8, half of that's 4. There aren't any unshared around the sulfur, so that's it. So the sulfur's formal charge would be 2. But if you took off these 2 electrons up here and put them down here, there we go, and same thing down here. So we have to erase a couple of these and a couple of these. Now we would have 6 minus 4, actually 6 minus 6, because there'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 2, 4, 6, 8, 10, 12 valence electrons around the sulfur. Half of that is 6, so 6 minus 6 equals 0. So the answer is D. All right, an ionic bond has to either be between a metal and a polyatomic ion, or between a metal and a nonmetal, as was in an earlier question. So the only one in which everything is covalent is that one. All right, and then number 19, which is pyramidal. You have to draw these to see, but NO3 looks like this, so it's trigonal planar. SO3 looks like this. It's also trigonal planar. ClO3, I think that's the answer. Let's see. Because you've got 7 plus 6 times 3 plus 1, so 7 plus 18 plus 1 is 26. Take away 6, you have 20, so you put 6 here, and 6 here, and these 2 electrons right here make it pyramidal. So once again, how I got to 26, 2, 4, 6 in the picture, 6 more here, 6 more here, 6 more here, and 2 more here, and that all adds up to equal 26. Okay, boron doesn't obey the octet rule. Remember, it goes into this trigonal planar configuration. H2CO I've already drawn earlier in an earlier question. There you go. So the only one that's pyramidal is C. Okay, which one contains 3 pi bonds? All right, 3 pi bonds means you've got to have either 3 double bonds or a double and a triple. So here I'm going to just draw one here. If I draw C, double bond O with an H here, and a C here, and a triple bond N, I think that does it. All right, 4, 5, 11, 15, 20. Here's the electrons, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So that's our picture. So you got a sigma and a pi, a sigma and 2 pi's. This one, HCCH, when you draw it, has to look like this. So it's got 2 pi bonds. Cn minus looks like this, I think. Let's see, 5, 4, yeah, 10. So that's 2 pi bonds. CO2 looks like this. 2 pi bonds. CO3 looks like this. Okay, so 1 pi bond. So the answer, A. The type of bond that results from uneven sharing of electrons, uneven, just reminding you that's polar. And which the bond angles which has less than 109.5. Milk carbon dioxide we just drew up here somewhere, right here. So that's 180. CH4 looks like this. 109.5. BCl3 looks like this. 120. Carbon dioxide, once again, 180. So H2S is our answer. H2S looks like this, but you've got this pair of electrons here, this pair of electrons here. So what happens is they kind of spread out, and that pushes these guys a little bit closer together. So minimizing the angle right here, whoops, right here between these bonds is going to be less than 109.5, about 104. Okay, square planar. This one, there are two answers. I've drawn CCl4 earlier up here. You can rewind. I don't remember where it was. There it is. So CCl4 looks like that, has 109.5 degree angles. So it's tetrahedral, not square planar. CF4 is going to have the same structure when you draw it, just tetrahedral. BRF4 has 7 times 4 is 28, and 7 is 35, and 1 is 36. This one, XE is 8, and 28 is 36. So both of these have 36 valence electrons. And the picture is going to end up looking like this. And that's square planar. So either one of these would have been the right answer, C or D. Which has sp3 hybridization. sp3 means 4 domains. So it looks like it's that one or that one. So the answer is A and B. Resonance. Resonance is when there's more than one place to put the double bond. You'll remember that when we drew SO3 up here a minute ago, right here, I could have put the double bond here, or here, or here. Could have gone in any one of the 3 places. So what happens is it doesn't go anywhere. It goes everywhere. So it's a blend of what you have is a molecular pi bond, where that pi bond could either be here, here, or here, so it moves around the whole molecule. All right, that's resonance. No pi bonds would be all single bonds. So when you draw the picture, it's going to have to look like that. Looks like the actual picture is like this. There's 8 valence electrons because you have 5 plus 4 plus a -1. You're taking away an electron because of this plus sign. So really you only have 8 valence electrons. So it's just going to be a tetrahedron like this. There you have it. And the T-shaped molecular geometry. I think I drew that one earlier. No, that was on a previous video. Let's see, I'll just draw it here in a second. Oh, no, don't see it. Probably did it. Here it is. The answer is BRF3. 7 times 3 is 21, plus 7 is 28. So 28 minus 6 is 22. Put 6 here, and 6 here. That's 18, so I have 4 more to put in. So that creates a T-shaped molecule. This one is trigonal planar. This one is just ionic. So the molecular geometries don't relate to that. That's trigonal planar. That one's linear. So the answer, okay, now 28 through 30, writing the equation. You know, you had barium nitrate. With potassium phosphate. Okay, so you're going to get barium phosphate. What happens is they change partners. Remember that? Combos, formulas, balance. So they change partners right here. And then you get potassium nitrate's your other one. You'll remember that polyatomic ions that are subscripts that are part of a polyatomic ion carry over. So the 3 and the 4 carry to the other side. The 3 here and the 2 here do not carry over automatically because they're not part of the polyatomic ion. Okay, looking at charges on your table, this is 2, that's 3, so you got to have a parentheses here. You're going to have 3 bariums and 2 of those. Then the nitrate and potassium are equal and opposite already. What, +1 and -1, so they're good. So those are your combinations, and now the formulas are correct. Last step is to balance. You look here, you have 3 bariums, so you put a 3 over here, which gives you the 3 bariums that you need, but it also has a side effect of multiplying the nitrates. So you have a 3 times 2 gives you 6 NO3s. On this side, how many NO3s do you have? I'm hoping that you said 1 and not 3. Sometimes people say 3, but if there were 3, it would look like this. Okay? So that's not what it looks like. Therefore, there's only 1 nitrate. I remember over here it was 3 times 2, so I need to put a 6 over here. That, in turn, gives me 6 Ks because it was a side effect. You have to multiply the whole formula. So 6 Ks mean I got to have 6 Ks over here. Well, there's 3 Ks, so I'm going to put a 2 in front. If I put a 2 in front, like that, then I have 2 times 3 is 6 Ks. That has a side effect of giving me 2 PO4s. See, I had a PO4 here, but there's a 2 in front. But on this side, look, I have 2 PO4s, and there I'm finished. All right, and that's the end of the multiple choice section.